Our planet is a dynamic place. It's always changing. Beneath our feet, a hidden world exists. Massive plates, like giant puzzle pieces, are constantly in motion. This is the world of plate tectonics. Imagine Earth's surface as a cracked eggshell. Each piece is a tectonic plate. These plates float on a layer of molten rock called the mantle. The mantle's heat creates currents, causing the plates to move. This movement is slow, about as fast as your fingernails grow. But over millions of years, it reshapes our planet. Continents drift, oceans open and close, and mountains rise. The Earth's surface is a tapestry woven by the intricate dance of these plates. Understanding this dance is key to understanding the forces that shape our world. It's a story of creation and destruction, of beauty and power.
Have you ever noticed how the continents seem to fit together, like pieces of a giant jigsaw puzzle? That's no coincidence. Millions of years ago, the continents were joined together in a supercontinent called Pangaea. Over time, the plates carrying these continents drifted apart. The Atlantic Ocean opened up. The Himalayas were formed as India collided with Asia. The Earth's surface was constantly being rearranged. The evidence of this ancient dance is all around us. Fossils of the same species are found on continents now separated by vast oceans. Mountain ranges on different continents share similar rock formations. The Earth whispers its history to those who listen. This continuous movement of the plates is not just a thing of the past. It's happening right now. The continents are still drifting, albeit slowly. The Atlantic Ocean is getting wider, while the Pacific Ocean is shrinking.
What drives this relentless movement of the tectonic plates? The answer lies deep within the Earth, in the layer called the mantle. The mantle is a zone of intense heat and pressure. This heat comes from the Earth's core, a sphere of iron and nickel at the planet's center. The core is as hot as the surface of the sun, radiating heat outwards. This heat sets the mantle in motion. Imagine a pot of boiling water. The hot water rises, cools, and then sinks back down, creating a circular flow. The same thing happens in the mantle. Hot rock rises from the core, cools near the surface, and then sinks back down. These convection currents in the mantle act like giant conveyor belts, dragging the tectonic plates along with them. The plates are constantly being pulled and pushed, creating incredible forces within the Earth.
The interactions between tectonic plates are not always smooth. Sometimes they collide, separate, or slide past each other. These interactions are the most dramatic manifestations of plate tectonics. When two plates collide, the immense pressure can buckle the Earth's crust, creating towering mountain ranges. The Himalayas, for example, were formed by the collision of the Indian and Eurasian plates. If one plate is forced beneath the other, a process called subduction, molten rock can rise to the surface, forming volcanoes. The Ring of Fire, a zone of intense volcanic and earthquake activity, circles the Pacific Ocean where plates are colliding. These collisions are not just destructive, they are also creative forces. They build new landforms, enrich the Earth's crust with minerals, and play a vital role in the planet's long-term evolution.
The Earth trembles. Understanding earthquakes. One of the most dramatic and destructive consequences of plate tectonics is the earthquake. These sudden releases of energy within the Earth's crust can cause widespread damage and loss of life. Earthquakes occur along fault lines, which are cracks in the Earth's crust where tectonic plates meet. As the plates move, they grind against each other, building up stress along the fault. When the stress exceeds the strength of the rocks, the fault ruptures, releasing energy in the form of seismic waves. These waves travel through the Earth, causing the ground to shake. The point where the earthquake originates is called the focus. The point on the Earth's surface directly above the focus is called the epicenter. Earthquakes are most intense at the epicenter and decrease in intensity further away.
Fault lines, cracks in Earth's armor. Fault lines are not just random cracks in the Earth's crust, they are zones of weakness where tectonic plates interact. They are found all over the world, both on land and beneath the oceans. There are different types of faults, depending on how the plates move relative to each other. Strike-slip faults occur when plates slide horizontally past each other. The San Andreas Fault in California is a famous example. Normal faults occur when plates move apart, causing the crust to stretch and thin. Reverse faults occur when plates collide, causing the crust to compress and buckle. Understanding the types of faults and their locations is crucial for assessing earthquake hazards. Areas along active fault lines are at a higher risk of experiencing earthquakes.
Measuring the fury, the Richter scale. Earthquakes vary greatly in their intensity. Some are barely perceptible, while others can level cities. To measure the energy released by an earthquake, scientists use a logarithmic scale called the Richter scale. The Richter scale assigns a magnitude number to an earthquake based on the amplitude of seismic waves recorded by seismographs. Each whole number increase on the scale represents a 10-fold increase in wave amplitude and a 32-fold increase in energy release. An earthquake with a magnitude of 3 or less is considered minor and is often not felt by people. An earthquake with a magnitude of 7 or greater is considered major and can cause widespread damage. The largest earthquake ever recorded was a magnitude 9.5 earthquake in Chile in 1960. It caused a tsunami that affected the entire Pacific Ocean.
Section 8. Nature's architects shaping the landscape. Earthquakes, while often destructive, also play a vital role in shaping the Earth's surface. They are nature's architects, constantly remodeling the landscape. Earthquakes can uplift land, creating plateaus and mountains. They can also cause subsidence where the ground sinks. The dramatic cliffs and valleys of California's Sierra Nevada mountains are the result of millions of years of earthquake activity. Earthquakes can trigger landslides, which can reshape mountainsides and valleys. They can also cause liquefaction, where saturated soil behaves like a liquid, leading to ground failure and building collapse. While these effects can be devastating in the short term, over geological time, they contribute to the creation of new habitats and the evolution of life.
Section 9. The human toll, earthquakes and our world. Earthquakes pose a significant threat to human societies. Their sudden and unpredictable nature makes them difficult to prepare for, and their destructive power can be immense. Buildings and infrastructure can be severely damaged or destroyed by ground shaking, landslides, and liquefaction. Earthquakes can also trigger tsunamis, which can inundate coastal areas far from the earthquake's epicenter. The human toll of earthquakes can be staggering. Thousands of people are killed or injured each year by earthquakes. The economic costs of earthquake damage can be billions of dollars. The 2010 Haiti earthquake, for example, killed over 200,000 people and caused widespread destruction in the Caribbean nation. The 2011 Tohoku earthquake and tsunami in Japan killed over 15,000 people and caused a nuclear disaster at the Fukushima Daiichi power plant.
Section 10. Living with Giants. Preparing for the inevitable. While we cannot prevent earthquakes, we can take steps to mitigate their impact. By understanding earthquake hazards, building safer structures, and developing early warning systems, we can reduce the risks posed by these natural disasters. Building codes in earthquake-prone areas often require structures to be designed and constructed to withstand ground shaking. Retrofitting older buildings to meet these standards can also reduce their vulnerability. Early warning systems use networks of sensors to detect earthquakes and issue alerts before the strongest shaking arrives. These systems can give people valuable seconds to take cover, stop critical infrastructure, and evacuate dangerous areas. Public education and preparedness are also crucial. Teaching people about earthquake hazards, how to stay safe during an earthquake, and what to do after an earthquake can save lives.
Section 11. Join the exploration unraveling Earth's mysteries. The Earth is a dynamic and ever-changing planet. Plate tectonics is a fundamental process that shapes our world, from the highest mountains to the deepest oceans. By understanding this process, we can better appreciate the forces that have shaped our planet and continue to shape it today. Join us as we continue to explore the wonders of our planet. Subscribe to our channel, Learn with Jaden, to learn more about the science. Together, let's unravel the mysteries of our incredible Earth.